Hi, my name is Diego Flores and today we're going to talk about differentiation rules. In this case, we're going to solve a problem which involves three different formulas and three different types. We have the quotient rule, the chain rule, and the derivative trigonometric functions. So in this case, we can observe that the problem has a situation where the quotient rule applies, which means that we need to identify u and v. So the values on top would be known as u, and the ones on the bottom would be known as v. So we need to establish them on the bottom. So now we need to find u prime and v prime, which in this case we can rewrite this function into sin of 6x minus 7 to 1/2 plus x. So in order to get u prime for this situation, we need to apply the chain rule just for this section. Dx would just follow a normal derivative property, which will be established later, but for now let's work with this one. So the chain rule would apply with 1/2 times the function, and now we need to subtract a complete whole number, and then we need to find the derivative, which would apply a trigonometric function, which would be the one from sine, which means that u prime, which in this case would be 6 of cos and 6x. Then we just multiply these two, the 1/2 and the 6, which would give us u prime would be 3 cos 6x times sine of 6x minus 7, so negative 1/2, and at the end we just add the x, which the derivative of x would just be left as 1. B prime, we just apply the same derivative properties as the x above, which would just be 2x.
So after getting the values of u, v, u prime, and v prime, now we can use the quotient rule to find the derivative. So once we put the numbers in the formula, we end up having this. This sin 6x minus 7 is written in the as a denominator because originally it was at the negative 1/2, and in order for it to be positive, you just have to put it in the bottom side of as a denominator. So once we have this, in order to have the same common factor, you have to cross multiply inside the bracket, and after you have the same common factor, you can multiply the x squared plus 1 times whatever you end up having here, and at the same time this negative 2x times all of this in the bracket, and then you can combine them. And after that, you will do tortilla with this in the denominator once you have all of this combined. Okay, so first we're going to focus on putting all of this numerator all together. So now that we have the common factor, which is sin 6x minus 7 to the 1/2, we applied it here and also in this side because it's a subtraction, so it has to be all the same. You cannot just do the common denominator in here and not in here. So now what we're going to do is multiply this by this and then this by this. So for the first one, you will end up having 3x squared cos 6x plus 3 cos 6x plus x squared times sin of 6x minus 7 to the 1/2 plus sin of 6x minus 7 to the 1/2. And then this is already all of this multiplied. Now to this side, it would be negative 2x times sin 6x minus 7, then minus 2x squared sin 6x minus 7 to the 1/2. So now all of this is now together. It is combined and it has the same common factor of sin 6x minus 7 to the 1/2. So now that we have this, you have to now apply tortilla because you still have the x squared plus 1 to the second power in the denominator. So this can be written as this times 1 over x2 plus 1 because it is a division squared. So basically on the numerator it will stay the same because it's times 1. In the denominator you just multiply x squared plus 1 to the second power times this, which will stay like this. And in the numerator you cannot simplify anymore, so this would be the final answer and the derivative of this question.